All right, everybody. Welcome to National Family Code Night. I'm John Pierce. I'm the director of Family Code Night. It's great to be with you guys here tonight. We are very happy to be doing this during Computer Science Education Week. This is our last of four National Family Code Nights this week. And we've had schools from all over the country, and tonight's no exception. We got dozens of schools with us from all over the place tonight. I want to just mention a few of them. The Kootenai Elementary School from Kootenai, Idaho. Very glad to have you guys with us. Idaho represents. Tanglewood Elementary School from Derby, Kansas. Martin Luther King Elementary School from Las Vegas, Nevada. PS 118 Lorraine Hansberry from Hollis, New York. You folks are coming in late at night. Freedom Elementary School from Freedom, Oklahoma. Sabine Elementary, or maybe it's Sabin Elementary School from Portland, Oregon, and a bunch of others. We're really glad to have you with us tonight, because this is really what National Family Code Night's all about. It's bringing children and parents together at schools and at home all over the country in these live stream experiences. And what it's really all about is finding the joy and the belief and the fun of learning how to code as you're a younger kid, because that's really so important. So welcome to National Family Code Night. Let me give you a little bit of background here. Family Code Night started out as an event that we helped schools put on, but when COVID came along, all of a sudden the schools could no longer do in-person school events. And so we started these live streams, and it turned out it really opened up some wonderful opportunities for us to reach far more people through these national live stream events. And so our whole evolution has been driven by that response. And I think we've been sort of thrown into the future in certain ways. One of the things that we've done, we used to be about just enabling this event at elementary schools. And we have since created this new organization called CS is Elementary. And in fact, that's our website, cselementary.org. And what we do is we try and provide services for elementary schools and families anywhere in the country to help K-5 children learn about coding and computer science. There's three big things that we do. This is a little screen grab of our website. We do National Family Code Nights, like what we're doing tonight. This spring winter and spring, we're introducing 4 more different family code nights. So children can start to learn about artificial intelligence, about cyber safety online, about data literacy. It's funny, you don't think of those as K-5 subjects, but in fact, kids really get them and they really understand them, and these nights are going to be a lot of fun. We also offer Code 5 courses. You can take these courses at home if you want, or in any school, and it provides a virtual teacher who comes and teaches classes either in the classroom or at home, and you can learn more about those at our website as well. And then finally, for any school that's already teaching computer science, we urge you to post your goals on our website. We have a map of every elementary school and every state in the country. And so any school that wants to post its goals to get recognition for what they're doing, we welcome them to do so. We also have a Parents Take Action function here. We really urge parents to be active. Elementary schools are driven by local control in our country. And so when parents get active and ask for computer science programs, it really matters. We give you some ideas for how to do that on our website. Urge you to get involved. So enough background, except for just one more important thing. I want to say thank you to Infosys Foundation USA. They're our partner and our sponsor, and they make all of our work possible. They've been our partners for the last couple of years, and it's been a great partnership, and we really appreciate their support. They also have the Pathfinders Online Institute. That is an online source for all kinds of really fun learning resources for computer science and maker education. And you can just Google Pathfinders Online Institute to get all those free resources. So that's about it. With me tonight, I've got my colleague, Julie Troy. She's going to be helping out on a couple of things. Julie, want to say hi and tell folks what you're going to be up to?
Hey, John, and hey, everyone. So you'll see me over, in the chat. I'm the CS's Elementary moderator there. So I'll be posting a couple important links for you guys, including the link to enter our contest tonight. But more details on that, the prize, how to enter, all coming soon. So be sure to stay tuned. We are going to draw that prize winner live tonight. So have fun coding, everyone, and I'll be in the background here. I'll see you soon.
Fantastic. Thanks a lot, Julie. And we may have Jessica on the live stream on YouTube. If we do, thanks, Jessica. Always great to have you with us as well. Let me give you, just tell you what Family Code Night is. It's a 1-hour experience where children and their parents can do their first hour of coding together. Sometimes children know a little more about it. Sometimes parents know a little more about it. But in any case, it's a wonderful way to start learning about computer science. We use puzzles from code.org. And as you'll see, it's really a fun way to start to learn about computer science. You know, we've been doing these for a couple of years. We've done them at thousands of schools all over the country and now through our live streams. And there's really one lesson, one thing that we really want all you kids to know more than anything else that we talk about tonight. You can code. The truth of the matter is, you kids are going to create a digital future that we can hardly imagine today. Think of all of the things in our world that have been transformed by computer technology. We used to buy everything in stores. Now you can buy anything online. You know, today we drive cars ourselves, but really soon cars are going to drive themselves, and they're just going to come and pick us up and take us where we want to go. You know, even in something like farming, tractors are now controlled by GPS satellites for super precise agriculture. In every field, computers are redefining everything about, not everything, but so much about how we do things in this world. And the one thing that's common to every one of those big changes in our world is computer science and coding, because people program the computers that make all these things happen. It's the difference between sitting and watching what's on your screen and creating what's on your screen. And kids, it's not just important for your future, it's also really fun. You can create your own computer games. You can create beautiful animations and art. There's all kinds of things you can do with coding. And so it's a wonderful thing to start learning more and more about, and this will be with you for the rest of your life. And so it's great that you're starting young. You're going to rule the future, kids, if you can just really learn this stuff. And it's not that hard to do. So glad you're here. Congratulations. And you can code. So what's our program tonight? Well, as I mentioned, we use Hour of Code puzzles from code.org. Some of you kids may have done Hour of Code in school before. This is sort of your chance to teach your parents what you're doing. It's kind of fun. Be patient with them. They may not know as much as you. But we also wrap some teaching around those puzzles. So we teach 6 big ideas about computer science that are illustrated by these puzzles. And so we'll be going back and forth between the puzzles and the big ideas. And then the final part of our program, as Julie mentioned, is our contest tonight. We have a neat prize that we're going to raffle off to one of you, and we'll show you how to enter that contest in a few minutes. Here's how our program is going to work. Right now, we're all sitting here together, either in the Zoom live stream or in the YouTube live stream, the Zoom meeting or the YouTube live stream. Welcome to be in either environment. And here is where I'll teach you the 6 big ideas about computer science. I'm also going to give you tips about the puzzles as we go, because they get a little trickier as you go along. So it's good to get some hints on some of these. Then in a few minutes, I'll ask you to open a second tab in your browser. And in that second tab in your browser, that's where you'll do the puzzles. And every few puzzles, I'll ask you to come back to the live stream to get some more tips about solving these puzzles and to learn our big ideas. So that's how our program's going to work tonight. Now, we also have a few rules that make the program more fun, and we hope you'll follow these rules along with us at home or in school, wherever you are in the country tonight. First of all, these are self-paced puzzles. What that means is when you finish one puzzle, you're automatically taken to the next puzzle. You can't get lost, so don't worry about a thing. You're going to be fine. You get taken right through the whole process. Also, there is no rush. We have kindergartners with us tonight. We have 5th graders. We even have middle schoolers with us tonight. You can go as fast or as slow as you want. And just the main thing is you're trying and learning. You don't have to race at all, so there's no rush. Everybody, we'd like to be working in a 2-person team. And we even have a name for the 2 people in the team. One of them is called the driver, and one of them is called the navigator. The driver holds the keyboard and does the coding for a particular puzzle. And the navigator acts as sort of an advisor. And the 2 of you talk about how to solve the puzzle. And you're going to need each other because these puzzles get a little tricky. So you'll want to figure out how to solve the puzzle together. But then the 4th rule down here, this is the hardest rule of all, because after every puzzle, you have to trade the keyboard back and forth, right? So you trade roles. Now, a lot of times parents like to kind of sit back and watch their children do these puzzles. And a lot of times the kids don't want to give up the keyboard, but that's not how Family Code Night works. You need to pass the keyboard back and forth to really have the full experience. because this is all about collaborating. It's all about working together and learning together. So that's the idea. Remember, you need to pass the keyboard back and forth after every puzzle and trade jobs. And you're all sharing your pairs. Each of you are sharing one computer. And as you probably know, anything that'll run a modern browser will be fine. So a tablet, a Chromebook, a computer, anything like that will be a great device for you to use tonight. The last rule, so to speak, is turn up your volume, set your browser to full screen so you can really enjoy all the cartoon characters that we're going to be playing with tonight. So that's about it. You're going to open a second tab to do the puzzles. You're going to come back here to the live stream to learn our 6 big ideas and for our time together. And that's really about it. So now we're ready to go. What we're going to do first is you're going to learn about the programming language that we're going to be using tonight to solve the puzzles. And the programming language is called Blockly. Now, I said that we're using puzzles from code.org, and code.org create a really neat little 2-minute video that'll teach you everything you need to know to get started using Blockly. So let's take a look at their video right now. It's very helpful. Pay attention because you really want to know each of these features. So a little bit of intro, and then you'll learn about Blockly in about a minute and a half. So here we go.
I was in 8th grade when I learned to program.
I first learned how to make a green circle and a red square appear on the screen.
You just learn these lessons, and there aren't that many of them, and you just eventually can get to the point where you can do almost anything that you want.
Computer science is just learning how a computer works and how it thinks so that you can teach it to do new things.
These days, what you can do in computer science is pretty much amazing.
I think it's the closest thing we have to a superpower.
In the next hour, we're going to play a game that will teach you the basic concepts of programming. Usually programming is all in text, but we'll use Blockly, which uses visual blocks that you drag and drop to write programs. Under the hood, you're still creating code. To start off, we're going to build code for a program that will help this angry bird move through a maze to get to the evil pigs that stole its eggs. Blockly is split into 3 main parts. On the left is the bird's maze, where your program will run. The instructions for each level are written below the maze. This middle area is the toolbox, and each of these blocks is a command that the bird can understand. The white space on the right is called the workspace, and this is where we'll build our program. If I drag the move block to our workspace and press run, what happens? The bird moves forward 1 box on the grid. And what if I want the bird to do something after the move forward on 1 box? I can add another block to our program. I'm going to choose the turn right block, and I'll drag it underneath my move block until the yellow arrow appears. And then I'll drop it, and the 2 blocks will snap together. When I press run again, the bird will perform the commands that are stacked from top to bottom on our workspace. If you ever want to delete a block, just remove it from the stack and drag it to the trash can. After you've hit run, you can always hit the reset button to get the bird back to the start. Now let's get those pigs.
All right, let's go get those pigs indeed. So now let me show you how you're going to get to the first puzzle to get started on tonight's program. What we're going to do is in just a second, I'm going to give you the URL to get to this page. You're going to come to this page, which is our start page for Family Code Night. And you'll see right up here at the top center, there's this great big link that says start the program. All you have to do is click that link. And now let's watch what happens. When you click that, you're taken to the first puzzle that we're going to be using tonight. And the first thing you'll see is that this window appears with the video that we just watched to teach you a little bit about Blockly. Now, if you want, you can watch it again, but you certainly don't have to because we just watched it all together. As you go through the puzzles tonight, you'll see other little videos pop up. And if you want, you can watch those. Again, you don't have to. I'll be telling you everything you need to know, but feel free to watch them if you like. Some of them are kind of fun. So here we are at the first puzzle. Every puzzle is organized the same way. There are instructions that tell you what you need to do. So in this case, can you help me catch the naughty pig? Stack a couple of move forward blocks together and press run to help me get there. Okay, so the directions are always right there at the top center. You drag the blocks out and snap them together to create your program to solve each puzzle. And you always can hit that X and X box to close any of these windows you like. And then you hit run to try out your program. And so that's the basic directions. That's how all the puzzles work. Pretty straightforward. Now, a couple of tips before you get going. First of all, you'll notice that the bird here is facing down towards the pig. What that means is that move forward for the bird is actually moving down. That is, you always have to think about the commands you're going to give from the bird's perspective. So if the bird is facing to the right, move forward will mean moving to the right. If the bird is facing to the left, move forward will mean moving to the left. So pay attention to which way the bird is facing to figure out which of these blocks you want to use. And as you saw just now when she was showing us the summary, you just drag out a block, bring it close to the other block, and when that little yellow arrow appears, let go, and they'll snap together and you can start building your program. Another thing I want to show you before we really get going here is if you'd like to view the instructions for each puzzle and the names of all the blocks in a language other than English, no problem. Right down here at the bottom left of the screen, you can choose any language you want. And so you can have the instructions in really any language you like. As we go along and go through the puzzles, you'll see that new blocks appear down here. Those are more and more powerful programming blocks. And I'll come back and I'll tell you how to use those blocks and what we can take advantage of. I think that's about it. So I think it's time for you guys to get going. So here's what we're going to do. What I want you to do is open up a second tab of your browser. And then all you have to do is go to that page I was just at. And that page is familycodenight.org/start. That's the URL that will take you to our start web page. And then you'll remember that big link at the top center of the page that says start the program. Click on start the program and you'll do just what I just did. You'll see the little video pop up. You can close that or watch it if you like, and then jump in there and do the first puzzle. And what I'd like you to do is when you open the second tab, when you go to familycodenight.org/start, I'd like you to do puzzles number 1 and 2. And it's only going to take you a minute. And then I'll come back and give you a couple more tips about Blockly. And also we'll learn our first big idea about computer science. So go ahead and get started. So you're going to go to familycodenight.org/start. That will bring you to our start page right here. You're going to click that start the program link right there. And then that's going to take you to puzzle number 1. So have at it, everybody. I'll see you in just a minute when you get done with those first couple of puzzles. And then we'll learn our first big idea about computer science. So see you in just a second, everybody. And just to remind folks that might be joining us a little bit late, you want to go to familycodenight.org/start in a second tab of your browser. You can learn about Blockly by watching a little 1-2 minute video there. And I'll call you back to this tab when we all get together to learn the big ideas about computer science, and I'll get together for various little discussions as we go.
Awesome. And thank you to everyone who is letting us know in the chat when you finish puzzle number 2. It's super helpful. Then we know, okay, awesome. Everyone's made it in and we are good to go. So
Excellent.
Continue to let us know. And we do have Jessica in the chat with us. So thank you, Jessica. And if you guys have any questions, please feel free to ask her. She is the code.org pro.
There we go. Very good. All right. Hey, everybody, come on back. Let's take a look at puzzle number 2. We'll give you a couple of quick tips. And so let's jump right on over there. So Puzzle number 2, you guys are probably getting used to this now. You're getting used to how to solve these puzzles. And puzzle number 2 is a lot like puzzle number 1, pretty straightforward. You're going to move forward and then move forward and then move forward again. So as you've learned so far, you're going to stack up these blocks, not a problem. You'll have your program going, and then you just come over here and click that run button, and you'll see if that solves the puzzle. And I think it does. A couple of tips about Blockly. If you want to move more than one block around, you just grab the top of your stack, click and hold, and as you drag around, you can drag more than one block around. One other thing, if you want to throw blocks away, drag them back into the blocks area and let them go. And that will make the blocks disappear. So that's how you throw away blocks. If you ever get stuck on a puzzle, you'll notice that the run button sometimes turns back into a reset button. You can just click that reset button, you'll go back to the beginning of this puzzle. Same thing happens when you hit this start over button over here on this side. Let's see. So I think those are the most important things. As I think I mentioned before, we're going to see new blocks appear down here, and I'll come back and explain how those blocks work. And so now that you guys have solved a couple of puzzles, I think we're ready for our first big idea in computer science. So let's go take a look at it. And the first big idea, what is a program? Well, you know what? You guys know what a program is because you've already written at least 2 programs if you solve puzzle number 2. Because what a program is a list of instructions that you create to tell a computer what to do. Amazingly enough, almost every program is designed this way. And so the programs that run the space shuttle or that drive cars or these incredibly sophisticated systems, a lot of times it's simply lines of instructions. In those cases, quite a few lines of instructions, but it's the same concept that we're learning tonight. A list of instructions that you create to control what the computer does. So congratulations, everybody. You've written your first couple of programs. Well done. And we're just getting started. So now I'd like you to go and complete puzzles 3 through 6. I'll be back in a couple of minutes. We'll get together at puzzle number 6. We'll introduce a really powerful new kind of block that's kind of cool. And we will learn our next 2 big ideas in computer science. So see you in just a minute, everybody. 3 through 6. Oh, and Julie, did you drop the start URL in the chat area?
Of course.
Of course. So anyway, if you showed up late, Julie's all over it. If you showed up late, go over there, click that start link in the chat, familycodenight.org/start. There's a little video there that'll introduce you to Blockly. And then you can catch up with us, no problem. So you can get started even if you showed up a little late. By the way, everybody, I want to just remind you one more time, don't forget to trade the keyboard after each puzzle. It's one of the rules. Let your parents have a turn, kids. Give you about one more minute and then I'll jump in. We'll get together on puzzle number 6. All right. I hope everybody's doing great out there and having some fun. Come on back to the live stream. If you want, you can watch Mark Zuckerberg talk about what we're going to talk about, but let's get together and talk about it here. So basically, what you've done so far, you've learned how to build a program, how to solve these puzzles. And when you look at this puzzle, you can see how to work it because you've already solved a few sort of like it. Here's our bird, and our bird has to go 1, 2, 3, 4, 5 spaces to get to the pig. Okay, pretty straightforward. We can just stack those 5 blocks out right here. And so we can just start dragging the blocks out and connecting them. But imagine this. Imagine if the pig was 100 blocks away. Imagine if the pig was 1,000 blocks away or 1,000,000 blocks away. Can you imagine how long it would take you to stack up all those blocks? Well, that's where this wonderful new block that's super powerful comes in that we're going to use in this puzzle. It's down here and it's called the repeat block or the repeat loop. So you drag it out, and now what this does is it lets you repeat as many times as you say whatever block or blocks you put inside of it. Well, that makes you super powerful because you can do the work of lots of blocks in just a couple of blocks. So you can drag the move forward block out. Now, in that case, in the case of this puzzle, I mean, is that what we want to use? He's moving forward all the way across here. So if he repeats the move forward block, that'll help him get all the way to the pig, right? I think that's the right block. So let's drag the move forward block and let's put it right inside the repeat loop and let go. Sure enough. And if it turned out that we actually were going 100 blocks, you just change that number. So you can tell the code how many times to repeat the block or blocks, whatever you need to solve a particular puzzle. So in this case, we're going to repeat it 5 times and let's run it and see what happens. All right, looks pretty good. Repeating that block. Pig looks worried. Excellent. All right. Now that is, in fact, it brings us to our second big idea in computer science, because a repeat loop is used in almost all programming languages. This idea of repeating code to make it much easier to write programs. So a repeat loop, you already know what it is. It repeats any block or blocks you put inside it as many times as you say. Now, this brings us to our third big idea in computer science as well. And in this case, the big idea is, what is code efficiency? Now, code efficiency, that may sound like sort of a big word, kids, but don't worry about it because you're going to understand it perfectly in about 15 seconds. So here's the way this works. We're going to go back and replay puzzle number 6. And remember, I said you can reset a puzzle by clicking the reset button here. So let's do that. And then let's throw away these blocks that we already used and throw them over here. All good. Now, code efficiency means writing your solving your puzzles and writing your code with as little code as possible. And there's a little scoreboard on every puzzle that will help you know how well you're doing. And it's these 2 numbers right up here at the top center of every puzzle. The first number shows you how many blocks you've used so far. And the second number shows you how many blocks you ought to be able to solve this puzzle in. And so in this case, we have 1 block that we're using so far, and sure enough, that's a 1. And it tells us we can solve this puzzle in 3 blocks. Well, if we wanted to solve this puzzle the old way, without using that wonderful repeat loop, we drag out a block and watch what happens to the first number when I add a block. Boom, 1 becomes 2. Now watch what happens when I add another one. I come in and, you know, as we just talked about, we can solve this puzzle by stacking 5 move forward blocks right here. It'll solve it just fine. But look at what happens when I add a 3rd block right here, or a 4th block, I should say. I come in here, let go, and watch the first number. It changes to 4, but it also turns yellow. That's a little alarm bell that tells you, uh-oh, I'm using more blocks than I need to. The idea of code efficiency is to use as few blocks as possible. And as we just saw, we don't have to use 4 or 5 or 6 blocks to solve this puzzle. We can do it in just 3 with that repeat block and the move forward block inside. And sure enough, we've used 3 blocks, and that's the number we're supposed to use. So on every puzzle, look up at those 2 numbers to see if you're solving the puzzle as efficiently as you can. And that is our third big idea in computer science. What is code efficiency? Solving each puzzle using as few blocks as possible and paying attention to those little scoreboard numbers up at the top center of every page. So code efficiency makes you much more powerful as a coder because you can do more work with less code. That's the idea. All right, very good. So we're about to go back to the puzzles, but before we do, we have one thing we want to give you a little preview of. Oh, this is our contest break. So we're going to be running a little contest tonight. Julie, can you tell folks how the contest is going to work?
Indeed. So this contest is very easy to enter, but we will need an adult present. So if you guys aren't already with the parent or adult trading keyboards, pair programming, make sure you get them. I'm going to post a link in the chat, and we're also going to put it up here on the screen. It's going to take you to a very simple form with a couple of questions. One of those is comments, and it's optional, but we really do love to hear from you guys. We'd love to hear how it's going so far tonight. So please do drop in a comment, as well as your parents' email, your parents' name, and we are going to draw a winner live tonight. And that winner is going to get an access token into Dash's neighborhood, which is a completely virtual world where you can program Dash using Blockly, exactly like you're doing tonight.
Excellent, excellent. And it's really fun. It's a virtual robotics playground. And we really appreciate Wonder Workshop. They donate this to the National Family Code Nights program. We really appreciate their support. And you may know the Dash robot, the physical robot with those little blue balls. These are really fun robots to play with. This is a virtual playground where you can program them exactly the same way. And it's a pretty neat prize. So we hope you guys win. And the URL to enter is right there, bit.ly/FCN robot. That stands for Family Code Night Robot. So we'll take just a minute here, give everybody a chance to enter. Just takes a minute, and hope you win, everybody. And then when you get done entering the contest, you can go back to the puzzles. And what I'd like you to do is do puzzles 7 through 9. Now, puzzle number 9 is a little confusing sometimes. So we'll do that one all together. So go ahead and enter the contest right there, bit.ly/FCN robot. Enter the contest and then do 7 through 9. I'll come back in a few minutes and we'll do puzzle number 9 together. So see you shortly, everybody. Just a couple more reminders. Remember, trade the keyboard after every puzzle. And if you're late, look for that start link, familycodenight.org/start. You can catch up with us. So we'll see you in a couple minutes at puzzle number 9. Good luck in the contest. So do remember to let us know what puzzle you're on. Julie, how are people doing? Are they up to puzzle number 9 yet?
No, that's a really good question, you guys. Looks like we've got Carter is at puzzle 11. Nice work.
Wow. Pretty good.
What
So,
about everyone else? Yeah, be sure to chat us. Let us know. Let us know how you're doing. You guys ready for number 9?
There you go. Jump right in there. Let Julie know where you are. All good. I think we're getting pretty close. I'll give you just a few more seconds. I was fooling around with puzzle number 8. I'd sort of forgotten that one. That's kind of a cool one. 2 repeat loops with a turn left in the middle. That's pretty neat. So.
All right. Now we got a lot of people that are at least at number 9.
Cool.
I think we're going to do this one together. Is that right, John?
Yeah, we're going to do 9 together because, here, come on back to the live stream, everybody. Let's take a look at number 9. The problem with number 9 is this gray block really can flummox people sometimes. It's a little confusing because you can't delete the gray block. So it's a little bit tricky. So you can't delete the gray block, but look at how far the bird has to go. He has to go all the way down here, then or over here, then he has to turn and come all the way down here. He has to turn again and go all the way. And we're supposed to do that in just 5 blocks. Holy cow. So a lot of times in these puzzles, what you want to do is figure out the pattern, the logical pattern of blocks that you might be able to repeat a number of times to solve the puzzle. And that's something to always watch out for. And in a lot of coding, that's the way it works, where you're looking for patterns so that your commands can be repeated over and over again, just to write efficient code and not have to stack up a dozen, 20 blocks to solve one of these puzzles. I mean, if we want to, we could go move forward, turn right? Those would be the first 3 blocks. Well, we'd be out of blocks already, but that's the way it's going to go. So anyway, the bird is going to go forward, and then he's going to turn right, because then he'll be pointing down and he can come down here and go forward. And then he's going to turn right again. And then he's going to go forward again to get to the pig. Do you notice anything about all those blocks? Forward, turn right, forward, turn right, forward, turn right. That's interesting because it looks like the blocks are repeated 3 times. Forward, turn right. And sure enough, that's what we're going to do. We know the bird has to start by moving forward. We know he has to move forward a second time. We know he has to turn right to make that first corner and be pointing down. But now look, we're out of blocks already. So stacking them down here below the repeat loop is not going to work. But that's why patterns are so important for this puzzle, because this pattern of blocks right here, we put the whole thing inside the repeat loop. Now what's going to happen? It's going to repeat the pattern that we've given it, the whole pattern 3 times. So it's going to go move forward, turn right, move forward, turn right, move forward, turn right. And if you look at the bird, that's going to get him all the way to the pig. So I'm going to go ahead and run this. And as I do, watch over here and you'll see the blocks turn yellow as they execute. That's as your lines of code, as your instructions are obeyed by the bird, it shows here as which ones turn yellow. So let's go ahead and run it and see what happens. First time through our pattern, that's once. Second time through our pattern, that's twice. Third time. Happy bird, sad pig. All right, pretty good. Now, I've been telling you, by the way, that you're writing code, right? Well, let me prove it to you right now. On each of these little screens here, there's a little button that says show code. Let's click on it and see what happens. Look at this. This down here is a programming language called JavaScript. JavaScript is one of the most powerful and widely used programming languages in the world. And it turns out that every block of Blockly that you use represents a line of JavaScript code. There's 2 kinds of programming languages in general. One kind is a block-based programming language like we're using tonight, Blockly. The other kind is a character-based programming language where you have to type every word, every letter of each command as you enter it. And so JavaScript is a character-based language. And sure enough, here are the commands in JavaScript for the blocks that we're using in Blockly. So I told you were really coding. You are really coding. So congratulations, everybody. And I'll show you one more thing super quick here as you get on to move on to the future puzzles. So far, the repeat loop, we've had to figure out how many times we wanted the command or commands to be repeated to solve our puzzle. Now we have a smarter form of repeat loop, because look down here, repeat until pig. What that means is it will repeat the block or blocks you put inside it forever until it accomplishes its goal. So your code is now going to be smart enough to know when it's been successful. So really nice new block. And that brings us to coding on. Go back in there, do puzzles 9 through 13. I'll come back and join you at puzzle number 13. We'll learn 2 more big ideas about computer science. So have fun, everybody. Let us know what puzzle you're on. Trade the keyboard back and forth. And we'll see you in a couple minutes at puzzle 13. All right, Julie, how's everybody doing out there? We about up puzzle 13?
It looks like it. We've got some people, still 10, 11, 12, definitely people at 13. Of course, you always get the speedsters that are like, I'm done. What's next?
Right. Well, there are definitely some hot shots out there. So congratulations to you guys that are really mastering all this. And, for you little kids or smaller, younger kids, don't worry about a thing. We're just so proud of you that you're here tackling these puzzles and doing a great job. Don't worry about how fast or slow you go. It's no problem at all. We do want to cover all the puzzles in our hour together tonight, so we'll keep on going, but we're going to show you how to solve all the puzzles here before long anyway. So don't worry about how fast or slow you're going. It's no problem. So I'll give you about 1 more minute and then we'll all get together at puzzle number 13. All right, everybody, come on back. Come on back to the live stream. We're going to tackle our next 2 big ideas in computer science. And this next one's one I kind of like. It's right here. And it is, there are no mistakes in coding. Now, what we mean by that is that making little errors in coding is just part of the process. And don't have to worry about it. Sometimes parents or kids can be sort of fearful. They're afraid to hit that run button. They're afraid they're going to break something. You're not going to break anything. Be fearless, everybody, and be willing to make little errors, because every time you make a little error, it's part of the process. It's part of learning. Every time you make a little mistake, you'll probably learn something else. So be bold, try stuff out, see what happens. And in fact, professional programmers, they don't worry about making little errors. They have a special name for them. They're called bugs. And in fact, if your code doesn't work, no problem. You find out why, you fix it. It's It's called debugging. Let's take a look at a little bug in puzzle 13. We'll see if we can't make something crazy happen here. So up on puzzle number 13, kind of a similar puzzle in some ways to the ones we've already tackled, in that we need to use that repeat until block to create a pattern that's going to get us to solve the puzzle. We've moved on to plants versus zombies, these other characters. And here's our zombie up here. There's our plant. And as you may know, the plant will eat the zombie if he gets a chance. So our zombie cannot go forward. We know that much for sure. So one thing we know is that zombies love sunflowers. And there's our zombie sunflower down there at the bottom. And so our zombie is trying to go all the way down each of these little steps here to get all the way down to the sunflower. But look, we only have 6 blocks to solve this puzzle. So this is a fairly demanding puzzle, but we have the repeat until block. Well, let's make a little mistake in our code and see what happens. What's the first thing that our zombie has to do? Well, if he goes forward, he's going to get eaten. So that's not what he's going to do. But if he turns left, he'll be pointing down, and then maybe he can move forward and work his way down here. So let's put a turn left block into our repeat until loop. Now, what do you think is going to happen if I hit the run button right now? Well, he's going to turn left, and then what's he going to do? He's going to turn left again. And then what's he going to do? You got it. He's going to turn left forever if I hit the run button. So this may not be quite the right, this may be a bug in our program, but let's run it and see what happens. There he goes. Oh my gosh, our poor zombie. Can you imagine how dizzy he's getting looking at that? Look at that poor little guy. Holy Toledo. All right, there's a bug in our code. We have not solved this puzzle yet, but maybe we're on the right track. So let's look at it again. Turning left is not enough. That'll just have us pointing down. But pointing down, we can then move forward. So let's try that. We'll move forward. Get in there. So if we turn left and move forward, then the next thing we have to do is turn in this direction. And remember, for the zombie, if he's pointing down, it looks like this is a right turn for us, but for him, it's a left turn. And that's pretty important. He's going to turn left. Oh, I'm sorry. He's not going to turn left. He's going to turn right. Let's change that. You know what? I was about to put a new bug in our code. He's going to turn right. So you can control which way he's going to turn with these little pull downs in each of the commands. So he's going to turn right. I had a bug in my code, and he's going to be facing down. Then he's going to move forward. And then here is where he's going to have to turn left. And again, from his point of view, it's a left turn. From our point of view, it's a right turn, but it's his point of view that matters. And then he'll be pointing over in this direction. So then he can move forward again. And if he moves forward again, it'll take him right down here below the plant. So in those 4 commands, turn right, move forward, turn left, move forward, he's made it down 1 step. But look, we're out of blocks. We've used all our blocks. But do we have a pattern here that if we repeat it until the sunflower, will he get all the way to the sunflower? Yes, he will, because it's the same pattern all the way. I'm going to run the code and watch the blocks execute as we go, and you'll see the exact same pattern over and over again will get him all the way down here through each of these identical steps till he gets down to the sunflower. Let's go. Okay, there's once through the pattern, twice. That sunflower could be 1,000,000 steps down, and our code would still make him get there. Very nice. So you can make little mistakes in coding. It's no big deal. Be fearless. Just try stuff out and see what happens. And it's great to learn how to fail. It's great to learn how to make mistakes and feel fine about it, because it's a great way to learn. One of the best ways to learn is to be fearless and bold, make little errors and learn from them. Our next big idea right now, what is a conditional? Conditional sounds like a pretty technical term, but actually, you know what, kids? You use conditionals every day. A conditional is what we call an if-then statement. Why do I say you use conditionals every day? Because it's how our brains work. If you're cold, then you put on a sweater. If you're hungry, then you have something to eat. If someone is nice to you, then you say thank you to them, right? If, then. It's the way our brains work. It's also the way code can work. It turns out that if then statements in your code can really help you, and it's called a conditional. And it means if this condition is true, then do this. So conditionals let your code see and react to the situations that they're in. So let's look at puzzle number 14 and see how we can use a conditional to solve this puzzle more effectively. Again, it's simply an if-then statement that you write into your code. Now, one thing about this puzzle, we have the dreaded gray blocks here again, but no sweat. We're going to solve this without any problem. But there is one tricky thing about this one. We already have 4 blocks that are in use, and we only get 5 blocks to solve this puzzle. We can only add 1 more block to solve this puzzle. Well, let's see what our zombie has to do here. Here's our zombie right here, and he wants to go here and then go all the way up here to get to the sunflower. He loves his sunflowers, right? Well, what's going to happen? Our code is going to control what he does, of course, and it tells him to repeat these blocks until he gets to the sunflower. And the first block he's going to repeat is move forward. Okay, that's good. He's going to move forward, and then he'll move forward again. Oh, but look, then he's going to bonk into this wall. He can't move forward anymore at the moment. That's where the conditional comes in. The conditional down here says, if there's a path to the left, what do we want to do? So that's the if then. If there's a path to the left, then do this. That's the conditional. Well, you can see that if he comes here and there is a path to the left that goes up here, what do you want him to do? You don't want him to just bonk into this wall here. You want him to turn so he can go up to the sunflower. And which direction does he have to turn? He has to turn left. And so our 5th and final block to solve this puzzle, turn left. So we stick the turn left block in there. And now what have we got? He's going to move forward. And if there's a path to the left, anytime there's a path to the left, he is going to turn left because that's what we code him to do. So let's go ahead and run this one. And as we run it, watch what happens. Every step of the way, he's going to ask himself if there's a path to the left. He's going to shoot off a little white ray to the left. Anytime there is a path to the left, he has to make that turn. So here we go. Brains. See his little ray? Oh, no path to the left. Oh, there is a path to the left. So he turns. There's no path to the left up here, so he can look all he wants, but he's going to keep going forward. There we go. All right, very good. So your code is getting smarter and smarter. You've learned about conditionals, if-then statements. We've learned 5 big ideas about computer science, and we are coming down the home stretch, everybody. So congratulations, you're all doing great. And now what I'd like you to do is do puzzles 14 through 17. I'll come back and join you on puzzle 18, and we'll learn our last big idea about computer science, and then we'll move on to that contest we were talking about and a couple other things to wrap up tonight's program. So we're in the home stretch. You guys are doing great. Again, don't worry about how far along or how fast or slow you're going. You're doing great, kids. Just have at it, have fun, check out the puzzles, and we'll see you at puzzle number 18 in just a couple minutes.
Hey friends, I just wanted to hop in here real quick and say this is your last chance to enter our contest. I'm going to post the links into the chats one more time. And I think we mentioned this, but everybody wins in this contest. Everybody who enters is going to receive a Code at Home pack chock full of activities that you can do from anywhere, anytime, and keep on coding. I know a couple of people in the chat have messaged me and said that they're having a lot of fun tonight. And that is amazing. And I just want to say coding is a ton of fun. And I think the more you know, the more fun it gets. So Congratulations, you guys. I'm glad you're enjoying it.
Oh, exactly right. Thanks, Julie. And make sure you enter. You want that code at home guide, and there's all kinds of fun stuff in there. I'm glad you mentioned that. That's terrific. And the entry is right there, bit.ly. FCN Robot. That's right. So anyway, enter the contest. Hope you win. And everybody wins when we send out a bunch of stuff to everybody who's with us tonight. Who enters the contest, that is. All right, I'm going to give you about 1 more minute, and then we're going to tackle puzzle 18 together and head on towards the end of our evening. All right, everybody, come on back to the live stream. We're going to learn our 6th big idea about computer science. And this is using a cartoon character you guys may remember from the movie Ice Age. Remember this guy down here, Scrat? You may remember he loved, what did he love more than anything else? Oh, that's right, acorns, right? So he loses his mind about acorns. And the last big idea we're going to be learning about is illustrated by this puzzle. And it is, we learned before just a minute ago about a conditional. And you'll remember a conditional is if this condition is true, then do this. If, then. Well, the 6th big idea is called an if-else statement. It's an even more powerful, smarter kind of conditional, because what it is if this condition is true, do this. But if something else is true, do this. So if one thing, do this. If something else, do this other thing. It makes your code smarter and smarter. A little confusing when you hear it, but when you see it, it's pretty straightforward. Let's take a look at this puzzle, which is a really nice use of that new block. And there's our new block right down there. And you'll see it's not like the other conditional, because it's not just if there's a path ahead, do this. It's if there's a path ahead, do one thing, else, that is otherwise, do something else. Right? So you're going to put 2 blocks inside this block to make the if-else conditional work the way we want to. And I'm pretty sure we're going to use this repeat loop because, as always, we love those patterns that we can repeat over and over again to make our code super efficient. What does our Scrat guy have to do? Well, he has to move forward, and then he has to turn left, so we'll be pointing up. Then he's going to move forward all the way up here. Then he's going to have to turn left again and move forward all the way down here. And then without taking any of these wrong turns here, we need him to go all the way down here and get to his beloved acorn. So that's what Scrat needs to do. We have 5 blocks to solve this puzzle, which isn't much considering how far he has to go. But we have these great blocks down here. So we know we're going to use this repeat loop because we got to figure out the pattern that we want to repeat over and over again. We have 3 more blocks to solve this puzzle. All right. So the if-else conditional, this is a really flexible, powerful block. It's pretty nice to use. Let's stick this inside here, and then let's think about what we want to do. So here's Scrat right here. And right now, repeat until acorn. It'll repeat the pattern we give him forever until its goal is reached. The first thing is, if there's a path ahead, what do we want him to do? Well, that's pretty straightforward. Here he is right here. And if there's a path ahead, do we want him to turn left or turn right? Nope, we want him to go forward. So move forward. If there's a path ahead, move forward. In fact, anytime there's a path ahead, move forward. That's the first part of the conditional. What's the else part of the conditional that'll solve this puzzle? And in just 1 more block. Well, you can see what it needs to be by looking at what Scrat needs to do right here. If there's a path ahead, he's going to move forward. He's going to move forward right to there. But now there's no path ahead, so he won't move forward. So that's the else. So what do we want him to do when he gets to this little square right here? We want him to turn left, because if he turns left, he'll be pointing right up here. So let's put the turn left in there. Now, we're out of blocks, but maybe we've solved the puzzle. Here's Scrat. He's going to move forward. There is no path ahead, so now the else kicks in. He's going to turn left. But now there's a path forward for him again. So he's going to move forward all the way up here. Oh, but right here, no more path forward. So what's he going to do? He's going to turn left because that's the else part of the if else conditional. And when he turns left, he's going to be pointing right down the home stretch here. And he's going to move forward because there's a path ahead. Now, why doesn't he turn left down this little dead end right here? Because there's a path forward. The first part of the conditional is if there's a path ahead. So anytime there's a path ahead, he is going to move forward. And as he's coming down the home stretch, you'll see he's going to be continuously shooting that little ray in front of him. And anytime that little ray shows there's a path forward, he's going to move ahead. So he's going to move all the way down here without any wrong turns and get to the acorn. So here we go. Here we go. And look, he's looking forward. And anytime there's a path ahead, he has to go forward. But if there's not, he has to turn left. So there we go. A happy scrat. All right, pretty good. Now, we're at puzzle number 18, and this is where we'll stop as far as helping you through the puzzles, but I want to suggest everybody should finish puzzle number 20. Code.org has a really neat little surprise for you at the end of puzzle number 20, so please go all the way through, and I'm going to show you in just a second how you can finish all the puzzles anytime you want to. So that sort of wraps our main puzzles. That's our sixth big idea, the if-else statement that you guys have now just learned about. So now the next question is, what now? What's next? We hope you've enjoyed your coding tonight, and there's so many ways you can learn more from here and have fun. And you can learn in school, you can learn at home, there's all kinds of ways. And kids, you might be a first grader or a kindergartner or a fourth grader, whatever, you can learn so much. And it'll really help you as you go on through middle school and high school and as you go out into the world. So there's a lot of stuff you can do, and it's really fun. So first of all, you can continue tonight's puzzles anytime you want. We leave that familycodenight.org/site page up all the time. So anytime you want, go back and start doing the puzzles again. And by the way, one thing I might point out, when you come back to the puzzles later, you can go to any puzzle you want to. You don't have to start with puzzle number 1. You may have noticed that I can jump around here by clicking on the little white dots at the top of the screen. So you can go directly to any puzzle. So let's say you've gotten as far as puzzle 10 tonight. You just come back, go to familycodenight.org/start, come back and click on that little number 10, and then you can start right here. So that's one thing that is in the what's next category. We hope you all have fun and come back anytime you want. The next thing that everybody can do, we're going to send out everybody a big ideas flyer, and it summarizes all 6 of the big ideas we learned tonight. What's a program? What's a repeat loop? What's a conditional? Everything we learned tonight summarized in this one little page. So it's a nice little reminder of the big ideas in computer science that you learned at National Family Code Night. The next thing everyone's going to get is this Code at Home Family Pack that we've been talking about. This has tons of resources. They're all free. They're all online. I think you'll really enjoy them. And they're at all different levels. In fact, one of them is a quite advanced website called Grasshopper that's offered by Google. It's free, and it teaches you JavaScript. And it uses the same kind of self-paced puzzles that we're using tonight. So it's kind of a nice way to start to learn JavaScript. And that and a bunch of other resources are all described here in the Code at Home Family Pack. So we're going to send that to everybody who enters the contest. Next, everybody gets a badge. Everybody likes badges, right? We did National Family Code Night. Be proud of yourself. Congratulations, kids. You did a great job. Congratulations, parents. You probably did a great job too. So everybody gets a badge. We'd love it if you wanted to post this to social media. Use the hashtag Family Code Night. It's great to spread the word about the work that we're doing and our efforts to get more and more computer science into everybody's home and everybody's school. So spread the word that you did National Family Code Night and impress your friends. So a couple more things. This is one thing we do that is a lot of fun. So we call this selfie time. And you may have seen some of our videos like this little screen grab right here. And these are all selfies that our families have sent in from all over the country. And we've got tons of these selfies. And we'd love it if you took a selfie of yourself right now, you and your mom or dad, take a selfie, email it to us at info@csselementary.org, and we may feature your picture in one of our videos or on one of our website pages. Now, remember, if you send it in, it's going to be public. We may well post it or use it in one of our videos. So if you send a picture in, we just be aware it could be on our website. So if you're good with that, we'd love to have you celebrate with us and spread the word about what we're doing and send us your happy picture like all these families here. We love this stuff. And, it's pretty neat when we're doing it with families all over the country and we can hear from you and see you out there. So we'd love to get your picture. Take a selfie, send it to us at info@cselementary.org. All right. And I want to just review our CS Elementary stuff. Please visit our website if you'd like to try and bring more computer science to your home or your school. There's all kinds of great resources. It's cselementary.org. We'd love to have you visit. There's also a parent engagement tab right here where you can send a message to your principal and say, hey, can we get more of these programs at our school? And that's a simple way to do that. I mentioned our Code 5 courses. They're all available free at Pathfinders Online Institute. And so just Google Pathfinders Online Institute, or if you like, you can go to this bit.ly link down here, bit.ly/infosys-code5. We have 5 different courses for children. One's on artificial intelligence. One's on, 2 are on artificial intelligence. We have a course for pre-readers. Using Code.org's pre-reader express puzzles. We have course C from Code.org for slightly older kids learning the basics of coding. And then we have a Scratch course for more advanced kids, maybe 3rd grade and up, to learn how to use Scratch using samples from the MIT website. That course actually is taught by our own Julie Choi, who you guys have seen a few times tonight. So we'd love for you to visit Pathfinders and use our Code 5 courses. They're all free. You can take them at home. You can take them at school. So we'd love to have you take advantage of those free resources. We also do live events. So everybody who liked this event tonight, so everybody who's joined has the option of opting into our list, and we'll let you know about upcoming events that we do. And we do, live classes. In fact, we're going to do something pretty cool coming up. We're going to do a dance party over the holidays. So you want to join us for that. I think that'll be pretty fun. And in fact, Jessica, who is on our YouTube stream tonight, I think Jessica is going to be doing the dance party with you. So I think you're going to have a lot of fun doing that. So make sure you're on our list and we'll always let you know what we've got coming up. One more thing, I mentioned that schools can post goals to get recognition for what they're doing in computer science. Just 2 numbers. Walnut Street Elementary School in Pennsylvania, just their 2 numbers are, they're going to teach 100% of their kids computer science, and every student will get about 10 hours a year of computer science instruction. That's all the goals consist of, but it lets a school get recognition for what they're doing. So if your school teaches computer science, urge them, or if you're a teacher, go to CS Elementary, post your goals, light your school up on the national map and your state map, get recognition for the great work you educators are doing out there. So we want to really recognize anyone who's teaching computer science, and obviously hundreds, thousands of schools are. All right, I think we're about ready to wrap it up. We have one more thing we want to take care of. Julie, anything else we should do tonight, or should we just go home now?
Oh, I think there's one important thing that everyone's kind of waiting around for.
Okay, all right. Let's see what happens here.
Oh, yeah, that's right. We do have our contest winner, and thank you guys all for entering. It was such a fun night. Thank you all for chatting. Thank you, Jessica. But without any further ado, our winner is, we have Amina McFerrin from Fort Stevens Elementary. So congratulations to Amina and family, and congratulations to everyone who was here and everyone who entered. You all win that Code at Home pack. And I know a lot of people are asking, is this tomorrow? Is this every day? Do we have more? And like John said, we are going to be back. Jessica's actually going to join us. We're going to do our dance party later this month. If you subscribe to the channel, you will get notified when that happens. If you join our newsletter and you said okay, you'll also get notified when that happens. And we look forward to seeing everybody again very soon.
Fantastic. Julie, thanks as always. Great job. So much. Appreciate the help. And everybody, you know what, kids? Congratulations. The big thing is trying, learning, making little mistakes, no problem, fast or slow. It's all good. You're learning about this stuff, and you kids are going to create the future. So congratulations, everybody. Thanks so much for coming tonight. Code on, and we'll see you next time. So stay in touch, get on our list. We look forward to seeing our next programs, and that's about it. Thanks so much, everybody. We'll see you next time. Good night.